Chasm is a compact, screw-based haptic actuator with high bandwidth and high expressivity. Chasm is slightly larger than a AAA battery and weighs about 15 grams. Chasm's main component is a lead screw and lead screw nut driven directly by a DC micromotor. Along with a linear encoder and motor driver, Chasm can render displacements of up to 3.4 millimeters and shear forces up to 4.8 newtons. Because of the directly driven lead screw and tight closed-loop control, Chasm can render shear forces, vibrations up to 170 Hz, and both at the same time. Chasm is controlled by a Teensy 3.5 microcontroller, along with a 12-volt power supply. Our firmware can drive two Chasm units separately, with a PID controller for each. To command Chasm's output, our firmware supports communication through the USB Human Interface Device class, which means that Chasm works with almost every host device and does not need a driver. Examples of such device include a PC running Windows, macOS, or Linux, an Android phone, or even a standalone virtual reality headset like the Oculus Quest. And together with a game engine, we can create unique and immersive virtual reality experiences with Chasm. In our first use case demonstration, we put two Chasm units on adjacent sides of a headgear prototype. In a simulated scenario in virtual reality, users are guided towards their destination using shear cues, telling them to turn towards the correct direction at each intersection. In our second use case, we use haptic gating to enhance the feeling of locomotion in virtual reality. When the user moves in virtual space, the two actuators alternate playing a slight tap on the temple to mimic footsteps. In our third use case, we put Chasm in a marker-like prototype. Chasm enhances the feeling of manipulating a marker or pointer in virtual space. We use the Oculus Touch controller as a proxy to track the hand. In the drawing demo, users can feel the marker contacting the board and a slight vibration when drawing. In the texture demo, users can discriminate between different textures by feeling different vibrations played by Chasm. In the color mapping demo, the intention is for users to feel the displacement map of the texture. A brighter color will cause a larger displacement on the actuator. The rubber ducky demo shows how Chasm can be used to create the presence of an object in virtual space. The cloth demo highlights how a custom-created waveform can create the illusion of a cloth snapping away from the user's marker. The weight demo demonstrates that together with a pseudo-haptic weight illusion, users can feel the weight of objects presented. Thank you for your time, and we hope to see you at the interactivity stations.